Looks like we're live. Hello everyone and welcome to yet another recreational programming session. So let's make a little bit of an announcement and officially start the stream. So let me pull out my Discord server, of course, and let's wait until it recomputes the layout. Every time I pull out the Discord, it becomes slower, and slower. Maybe this is something with my laptop, maybe this is something with Discord. You never know. With this modern software, you never know. Live on Twitch, and what are we doing today on a twitch.television website? That's a very famous website that everybody uses these days. So today we're doing natural language processing in Rust. How about that? Doesn't it sound epic? I think it sounds pretty epic. So let me give the link to the Twitch channel where we're doing all of that, twitch.tv/studying, and I'm gonna ping everyone who's interested in being pinged. There we go, the stream has been officially started. So what are we doing today? Today we continue developing the local search engine in Rust. You can find the source code of this thing in the chat if you're watching on Twitch, or in the description if you are watching on YouTube, right? So maybe eventually this entire thing is going to be on YouTube, who knows? Right, and the entire idea is that to have like a very small, like a very specialized, maybe not really that specialized, but you know, very small search engine locally on your machine that works without any internet. So essentially you would give it a folder with some documents, right? So XML documents, TXT documents, Markdown, PDF and stuff like that. It will go through all of the files, through all of the documents in that folder and index them. Right, you know, Google indexes the websites, we're going to be indexing the local documents, and then you would be able to serve that index, meaning that you would start a local web server, you will go to that local web server on your machine, and you would be able to put Google-style queries and search within those documents. Right, so to achieve that, we're using something called TF-IDF, right? So it's a term frequency inverse document frequency. We discussed that multiple times on the streams. I really recommend to watch the previous streams on the topic. So I created the whole playlist on YouTube daily channel. I'm gonna put the playlist for C Rust in the description after the stream, right? So that's essentially the thing I'm going to do. Right, so we're using TF-IDF, term frequency, inverse document frequency. And let's take a look at how it works. We already have something working, right? So I'm going to go to the source code of this entire thing. So it all started with trying to index the docs.jl documentation for OpenGL. So here is the entirety of docs.jl documentation. And I'm going to do cargo run. Of course, I'm going to want to do all of that in release because it's faster. And I'm going to say index that specific folder in there. And as you can see, it's going through all of the files in that folder and indexed them, right? It should go relatively fast because we optimized that some time ago. Right. Any minute now, right, and it indexed everything, right, and it put everything into a JSON file, which is of the size of 3 megabytes, right? So we also experimented with using SQLite instead of JSON, but I'm still really not sure if I want to use SQLite. So for now, we're using JSON. And after that, we do the following thing. We say serve, and we serve that specific index JSON that we created. Right, and what it does, it starts up a local HTTP server, literally local HTTP server, and you can go in there. So we don't really have a fancy, you know, design or anything like that. We're gonna work on that at some point. And you can start like typing queries in here. For instance, I wanna find something like, how do I do linear interpolation in the OpenGL, you know, shader language? I'm gonna do GLSL. Linear interpolation, right? Linear interpolation, and it suggests me things like smooth step, right? So, and the thing that I'm care about is actually mix, but in any case, it actually brings up the things that are relevant, right? So I can try different things like how to bind a texture, right? So, and it, yeah, it literally gives me the GL bind texture, right? So what's funny is that this kind of relevancy is relatively easy to achieve with just the TF-IDF, very old technique that has been used in information retrieval for decades, and it still works quite well. It still works quite well. So we've got some subs. We actually got quite a lot of subs. Holy shit. Okay. I didn't expect that. So, Yogi Off, thank you so much for Twitch Prime. Actually, it was 4 days ago, but I mean, I think I still need to acknowledge people who were subscribing offline, right? So, Antonili 2000, thank you so much for Twitch Prime. Fabio HBF, thank you so much for 2 months of tier 1 with the message "Sojin cool." This is very cool indeed. Thank you, thank you, thank you. Pawn Theory, thank you so much for 17 months of tier 1 subscription with the message "Happy Language Processing Stream." Thank you. I hope you'll enjoy it as well. So another tier 1 subscription from Compotic Dot, thank you so much. And hello everyone is the message. Hello, hello, hello. Junior Freitas, thank you so much for tier 1 subscription with the message Tsodin Weeb, Tsodin Weeb indeed. And another sub from Too Dope for a username. Thank you so much for tier 1 subscription. Thank you, thank you, thank you. So, right. But everything is cool and all, but there is some problem with the current design, so to speak, right? So for instance, if I search for GLSL linear interpolation, right, linear interpolation, I get one set of results, but then I can say, okay, linearly interpolate, like, or something like that, how to linearly interpolate in GLSL, right? So, and then I get a completely different set of results. Now it actually brings up mix at the top and there is no smooth at all. I can also change this kind of thing, and also it changes some stuff at the bottom. So this is the thing. This is a flaw in the design of our search. It considers linear and linearly a different term, right? So yeah, so if linearly is used more in one place, it's gonna rank it higher, but maybe we want to actually so essentially consider these two things the same stuff. And apparently this is actually a quite common situation in you know, information retrieval or in search engines and stuff like that. This is a very common thing where you basically want to consider like different, basically want to ignore different inflections of the same word, and it's not exclusive to English. Something like that happens in all languages, like Indo-European languages, maybe like in all languages, like in general. Right, and this is usually solved with something called stemming. Right, so let's Google that. Stemming. So let's take a look. So in linguistic morphology and information retrieval, stemming is the process of reducing inflected or sometimes derived words to their word stem, base or root form, generally a written word form. The stem need not to be identical to the morphological root of the word. It is usually sufficient that the related words map to the same stem. Right. Essentially, stemming is just like going to be basically removing things like li. Right. Right. So I don't know, something like cat, catted. I don't know. And the stemmer should actually remove ed from here. And different languages are going to have different rules on what is considered like sort of like the noise of the word. I'm not sure if it's a good word, to describe this kind of stuff, but yeah. People developed like entire programming languages just to write algorithms for stemming. Suffixes, yeah, like in different languages you're gonna have different suffixes. Thank you so much, chat, for helping me with words. Right, so one of these languages, I think it's almost the only one, right, but you basically can Google things like English stemmer, right? So stemmer, and the only basically result that's going to pop up in the search engines is going to be about a language called Jesus Christ, Snowball, but for some reason DuckDuckGo isn't capable of actually showing me that, so maybe we can go to Google. Let's switch to Google very quick. Yeah, there we go. So there's a language called Snowball, right, which is essentially a language that is designed for writing stemmers, right? So here is the article that describes like a stemming algorithm for English and how different like words are stemmed. And then at the bottom, there is an algorithm described in a Snowball language, right? I personally don't really know the Snowball language, but it actually sounds really fascinating. Maybe at some point I'm going to learn it and maybe do something with it. But at the same time, I'm not even sure if knowing this language is that useful for me, because implementing the stemming algorithm sounds like a one-time problem, right? You sort of like implement a stemmer from a language and just forget about it. But at the same time, maybe you can always improve existing stemming algorithms. Right, maybe you can improve existing stemming algorithms, but that's like you have to be like a linguist to do this kind of stuff, so I don't know. Right. So anyway, so if you take a look at the official website, right, so there's like a newer version of the website. Yeah, Snowball. So I'm gonna put this thing in here, right? So you can find. I'm gonna put it in the chat, and I'm also gonna put this entire thing in the description, right? So Snowball programming language. So the cool thing about this Snowball programming language is that it's not really a conventional programming language, in the sense that you like write a program in it and then you execute the program. It actually compiles to other languages, right? So it compiles to things like Ada, C, C#, Go, Java, JavaScript, Objective Pascal, Python, and Rust. So a stemming algorithm written in that language can be compiled down to Rust, thus integrated with our project. Which is kind of cool, which is precisely what we want. We want to have like a stemming algorithm built into our search engine. Right, so there's different algorithm on this website, right? So for different languages and stuff like that. So I think there's even like a demos. Yeah, so there's a JavaScript demo. Right, so this is actually pretty cool. We can test it out, right? So we can take a look at the linear, for instance. Let's actually try our example, right? So linear, and linear, as you can see, is in fact linear, right? So, but if I put linearly, it will actually, I didn't really stem it exactly as I expected, so maybe this thing is actually useless for us. But this is only one stemmer. We can try different stemmers. Oh yeah. Yeah, it's a classical bug where I have to open any other native application, then try to do a pop-up in here, and only then any other pop-ups within the Chromium will finally work. Yes, thank you very much. Very cool. All right, so do we have just... Okay, so there is English. Oh, look at that. If we just use the English stemmer, right? If we just use the English stemmer, it actually cuts out li, right? It actually cuts out li. So linear and linearly will map to the same thing. Isn't that cool? I think it's pretty cool. Right, so for instance, we can do goat or goated. The same thing. Right, and so we can also take a look at some stuff in here. For instance, there's a classical example in Russian language. So since the second language that I speak is Russian, right, so I can actually verify some things. The classical example in Russian, I think, which kind of makes it difficult to stem properly, is voda and voditelь, right? So the first thing means water, right? So this is water, and this one is a driver. So the thing is, in Russian language, both of these words have the root vod, right? They both have root vod, but they are not considered the words with the same root. These are two different roots that just happen to sound the same. And the reason why they're not considered the same is because these two words literally have different meaning. By stemming the words to its root, you're basically losing kind of information about the word itself. So because of that, these two roots are considered different. And I wonder, like, it has a Russian stemmer, how it will react to these two words. Will it map them to the same stem? If it will map them to the same stem, we're literally losing the information, right? I'm actually really curious, right? So will it map it? Okay, so voda, which is water, was mapped to vod. Okay, so would vodитель, which is driver, mapped to the same... No, it won't. Though, technically, it is not a correct root. It is not a correct Russian root. It is a different stem, which means that when we strip these two words down to their stems, they're going to be considered different words. Okay, this is actually a very good stemmer, right? So the thing about stemmers is that the stem is not necessarily has to be like a correct root. It has to be some combination of sequences, right, to which related words map. If several words map to that specific combination of characters, they're very likely related. That's kind of the point to the stemmer, right? You see what I mean? So that's the difference between a stem and an actually correct root of the word. Right, so because of that, there is like two different terms in the linguistics, I think. There's a stemming, right, and there's also lemmisation, I think, or lemming. Lemming is essentially stripping down the word to its like base form, which is linguistically correct. Stem does not necessarily has to be linguistically correct. It has to be just some combination of characters to which related words map. If I understand correctly, I'm not a linguist and not a specialist in NLP, but this is how I understood by just Googling around and doing things. So I hope that makes sense. I hope that makes sense. Right, anyway, so that's actually pretty cool. There is a stemmers for different languages, for a lot of languages, like I would say the major ones. Right, so and maybe we can use all of them. So I'm really curious. So maybe we can just like download and compile this compiler. So as far as I know, I looked at the downloads, and you can only download precompiled like a library version of the language, right? And you can't compile the binaries. So. And there's a very interesting reason for that. We do not make binary distributions of Snowball available. There are simply too many different platforms, architectures, and languages to support. If you're willing to make such binaries available for others and can provide at least some measure of support for ensuring that they work, feel free to contact us. Contact us. I don't remember how to pronounce this one. I'm sorry. And we'll add a link to your work from this website. Right? So, which sounds very fucking relatable, right? So there's just too many goddamn Linux distributions, and if you compile a binary for one Linux distribution, it is not guaranteed that it's going to work in a different Linux distribution, unless you actually statically compile it, right? So, and essentially include like all of the dependencies, all of the libraries into the executable, and even then there could be problems with slightly different versions of the kernel and backward incompatible syscalls and stuff like that, but I don't think it's that big of a problem these days. Maybe, I don't know. So this is one of the reasons why we have libc. Libc sort of like serves as this sort of buffer between your program and the kernel. So if some of the syscalls of the kernel change, the libc tries to adapt those syscalls to your C program, so they don't have to worry about this kind of stuff. But at the same time, we have problems with libc ABIs. So the very problem that the libc is supposed to solve for us, right? Backward incompatibility of APIs, and then you fuck up something with the libc compilation. Now you have ABI problems all of a sudden. So, but that's a story for another time. That's a story for another time. So, by the way, so sorry for ranting this much these days. I don't know. Maybe I'm just getting old, and tired of this bullshit. You know what I mean? All right. So Snowball, of course I'm going to give it a star. So here's the repo. It's relatively active. So the last came in from November 16th. So which is last year, which is fine. So let's actually try to clone it and see what we can do with this thing. Let's try to explore that. So what I'm going to do, I'm going to clone it to git clone depth 1, right? So we're not going to clone everything because there's almost thousands of commits in here. So let's just do a one commit at a time. Right, cloning into Snowball. All right. So, and this is only one commit. All right, Snowball. So what do we have? We have a make file, but do we have a configure? There is no configure script, so there's only one make file that is not automatically generated, which is handwritten, handmade, handwritten make file, which is kind of cool. All right, so let's actually try to do that. Maybe I should have actually did like a several threads. So I usually do 5 threads, but I'm also streaming, so I need to leave a little bit of the resources for myself. So STEM UTF, Irish, Italian, Russian, Spanish, Swedish. Cool. All right. So I have no idea what it created. Does it have like something like install? Probably doesn't have. So let me find files that are executable. So I'm pretty sure it will create an executable file. So let's actually find all the executable files. Okay, there we go. So there is a Snowball executable. Right, that's cool. There's also stem words. So maybe this is something that we can use as an external thingy. It's waiting, so I suppose it is waiting something from the standard input, right? So it's kind of difficult to input, to use standard input from within the Emacs compilation mode, so it's easier to actually do something like this, right? So I'm going to cd here and do stem words. So if I do something like linear, yeah, there we go. So it actually accepts that through the standard input, apparently. So it means I can have like a file full of words and it will stem them for me. This is actually a very useful tool. Does it support like a Russian language? Yeah, no, it doesn't support Russian language. I was... okay, so can I do help? There is a help, look at that. Can I specify a language? Yeah, I can. Okay, so that's pretty cool. So if I say something like L Russian, yeah, it works. Okay, so that's a pretty cool tool. Right, so I can already use stemming without integration with the language just by calling an external tool, you know, the FFmpeg approach. It's kind of interesting. Like you can say that, oh, that's not convenient, right? So it's kind of lousy architecture when you depend on such a thing, on a like an external tool. But this is literally how you're supposed to use FFmpeg, right? So if you're writing like an application that does video editing or video processing, you're supposed to like call FFmpeg as an external tool. Right, and it has ability to accept like video stream through a standard input, and you're supposed to feed it video stream through the standard input. And the reason why it is like that is because the original library, so there is also a library version of FFmpeg. The library version of FFmpeg is huge pain in the ass to use. It is so fucking painful to use, it is easier to just call an external FFmpeg. And FFmpeg, like anyone who worked with FFmpeg, you guys know that by itself, this thing is also a huge pain in the ass to use. Right. So imagine how much pain in the ass does the library have to be to justify calling FFmpeg as an external program. Just think about that, just for a second. Anyway, I'm joking. Anyways, so what I'm saying is that we can already go the FFmpeg route and just call this thing externally. Sounds cool? Sounds Gucci? Sounds Tamaguchi? We can already do that, but we're not gonna do that. All right. So the other thing that we have is a Snowball, right? So let's take a look at the other executables. We have some Polish scripts, or actually Perl scripts, right? PL is a Perl script, right? Yeah, it's a Perl script. So we also have generate. I mean, who uses Perl in 2023? Who uses Perl 23? I don't fucking know. Snowball. Okay, so Snowball is the compiler, right? So you supply source code in the Snowball language, right? Let's take a look. So as far as I know, there was some. They're probably located in algorithms. There we go. So here are the algorithm in SBL, and I wonder if Emacs has Snowball mode. That would be actually kind of cool. So let's actually do this package. Could be Prolog 2, yeah. I mean, but nobody uses Prolog in 2023, especially. Right. So Snowball, yeah, no, there's no such thing in here. But anyway, we can try to understand what the fuck is this language. So I suppose this is how you define two integers. I never programmed in this language. In fact, I'm basically seeing this language for the first time, for the second time. Okay, I saw this exact algorithm before the stream, so I'm seeing it for the second time. But something tells me, something inside of me tells me that here we're defining two variables with the name P1 and P2, and those variables are floats. I think this is a definition of two floats. What do you guys think? Like, something inside of me tells me that this is a definition of two floats. Probably, I think. So, and this is a definition of one boolean, right? Okay, so also here we define routines, right? So we have routines like prelude, postlude, lude, mark regions, short v, R1, step A1, and so on and so forth. And there is a bunch of exceptions. If you think about it, like, I was actually curious, why the fuck do you need a separate language for stemming? Why the fuck do you need a separate language for stemming? Because, like, why can't you use like a normal programming language? But stemming for natural languages primarily consists of a lot of corner cases and exceptions and if-defs and if-defs and if-defs, which is kind of painful to write in a classical programming language. So maybe Snowball actually makes it easier to describe set of different exceptions and corner cases and stuff like that. Maybe it does make sense to have a specialized language for stemming, you know what I mean? That's actually interesting. So there is externals. An external is stem. I suppose. So let's take a look. Do we refer to stem anywhere? Okay, so define stem as this thing and define postlude. I know for sure that the postlude is a routine, right? It is a routine. And stem is an external, but it's not a routine, but they're both defined as routines. So, which kind of tells me that externals are routines, right? So even though stem is not part of the routines. You know, what's cool is that I'm actually guessing all of that based on the appearance of the language alone. I don't have a manual or anything like that. And we have groupings. I have no idea what that is, but yeah. So string escapes, we have empty string escapes. So now we define v. Do we declare v anywhere? So we know that v is a grouping. Okay, this language is very interesting. So you basically declare all of the objects and their type up front, and only then define what they are later. So it feels a little bit old. So this was a thing in old languages like Pascal, for instance, right? In Pascal, you also first declare all of these things, and then you define them. So there's always in these old languages a separation between declaration and definition, right? So it's like in the modern languages these days, we're starting to moving towards just like clamping declaration and definition together because it's just easier. But in the past, it was easier to first have declaration and then have a definition. And there is a very specific reason for that, by the way. There's a very specific reason for that. It makes it easier to implement one-pass compilers, right? So essentially compilers that go to the source code once and check everything and simultaneously generate everything, right? So quite often you may have objects that cross-refer to each other in a circular way, right? So you can have something A that refers to B, and then B refers to A, right? How can you declare, and then like how can you define this kind of objects without declaration? You would have to go through the source code at least twice. You would have to go through all of the source code, just gather all of kind of objects you have, and then already resolve recursive links and stuff like that, which makes it kind of difficult. And in the past, computers were probably slow, and that's why it's easier to first declare everything that you have, so you don't have to go back, and then you can process everything that you define. Does it make sense? I'm not sure if it makes sense, but that's what I feel like about old languages. Not sure if it makes sense. Anyway, so and different procedures, we just have different actions, right? So y found, and y found basically refers to y at the end. It's a very interesting language. Maybe I should learn it at some point. Yeah. Anyway, let's try to compile this goddamn language, right? So let's try to go and do Snowball, right? Snowball algorithms, and let's do English SBL. Right, so we didn't like something. I'm not sure what exactly. Please include O option. Oh, okay, so you have to specify the output name. So how are we gonna call this? Uvu. Right, so I want to call it uvu so we can instantly see what exactly it generated. So, and now I can search uvu, and as you can see, it generated actually two files, two C files. So we have a header, right, and we have C, right, and here is basically the stemmer. This is actually kind of cool. So that means I can just link with that file and use the stemmer from C. And does it support like several languages in here? I'm actually curious. What kind of language does it support? Oh, okay, so you can do Java, C#, C++, Pascal, Python, JS, Rust, Go, Ada. So you basically need to specify the language. So in our case, we're using Rust. So can we just use Rust? So I'm going to do algorithm English, and I'm going to do uvu, and I suppose you have to say something like Rust. Okay, and we have a res file or s file. Okay, generated by Snowball, which is kind of cool. No snake case. Oh, it just like disables a bunch of just disables a bunch of warnings that the author was not happy about, which is understandable. Right. So and we have this kind of shit. Yo. And it just exports this stem procedure. So essentially, it probably maps the procedures. Yeah, so we have postlude, we probably have a prelude. Yeah, so each routine in Snowball actually maps to a procedure in Rust. In Rust, they're called functions or something like that, right? I suppose. Any unsafe? That's a good question, actually. Let's actually... No, there's not a single unsafe in here. Right, so the stemmer doesn't really need any unsafe. Right. So a stem, it accepts a Snowball environment, and I wonder what is a Snowball environment? Where is it defined? It is... Wait a second. It is not defined anywhere. It is imported for something like Snowball, but it's not defined anywhere. So is there something like mod snow? So it generated something that depends on something else that is not. So it didn't generate a self-contained code. Let me actually double check that. Really, I'm slightly disappointed. Not gonna lie, just a tiny bit disappointed. So if I do something like println hello world. Right, so and I'm gonna do rust c main.rs, right? So okay, so that's cool, and then I can just run this entire thing, and it says hello world. Okay, that's very cool. Then I can say something like mod uvu, fuck you, Aki, uvu. Okay, so Man, I'm disappointed. I was hoping that this thing will actually generate like self-contained programs that I can literally link with my original search engine and don't worry about third-party dependencies because everything is fucking included. But no, fuck me, apparently. Which is fine, I kinda got used to that. I'm a professional software developer. Professional software developers kinda got used to hearing fuck you every single time. So, anyway. So what does it need? What does it need? It needs a snowball environment. So can we just find it? Maybe the library with which we have to link all of that shite is located right in there, right? So let me try to do RG, right? So because we are Rust developers, we're supposed to use rib grep instead of that boomer grep, right? Dab, dab, dab. That's why it's called rib grep, because grep rest and fucking pissed. I'm sorry, I think I had too much tea. So, okay, so let's actually do RG vim grep, and we're gonna do snowball environment, right? So where do we have, okay. Oh, there's literally a folder called Rust. A patch? Rust pre 1.27 compatibility. You need to fucking patch Rust for this shit to work? What? This shit is getting more cursed and cursed the deeper I go into that. Like, what the fuck? Man, I just want to remove a couple of characters out of words. Why do you have to patch a fucking compiler for that? Man, I mean, anyway, let's take a look. Okay, there's a folder called Rust. So let's take a look at the patch. Okay, something about dynamics. So this is actually a very trivial thing, but this is for the like very old version. I have no idea what kind of version do I have. Right, so let me take a look. Version. Well, okay, so it's something very old. So it's probably not a thing anymore. So we're gonna basically conveniently ignore this entire thing. So okay, what do we have? We have cargo toml. No third-party dependencies. I can appreciate that. So we also have some shite in here. So this is a build script. I really like that. We're literally generating Rust in here, right? So that's pretty cool. Okay, so we also have SRC. So this is some sort of example. And we include snowball environment, right? So there's a snowball, and here's a snowball environment. Okay, so here it is. So that's what we basically have in here. So, but this is like an entire project. Can I just build this project? Do I have to do something with that? Cargo build. This is not how we do that. I'm an idiot. Okay, so what do we have? So compiling test app. Okay, it built some sort of test app, so it was actually successful, surprisingly. Alright, so can I now just do target test app? So it's probably something like debug test app. Alright, so, and we can test. The input consists of list of words to be stamped. One per line, words should be in lowercase, but for English, blah blah blah. Okay, so input and output are optional, so I suppose if input is not provided, it's gonna use the standard input, right? So let me see. So input arg is defined as optional, and if it is not provided, it's basically using standard input. Okay, that's pretty cool. Who needs documentation? I literally can see what I need in the source code, right? It's literally written in the source code. You don't need documentation. Cap. Yeah, it literally says that in documentation. So if you write a simple code, right? So what kind of flag I'm interested in? I'm interested in -i flag. I found a -i flag. I can see it sets a variable input arg, and it set it as an option. It sets it as an option, and the initial value of this thing is none. That means initially it's not set. So then we go down and we see, okay, so here we check whether it's set or not set. And when it's not set, it just uses standard input. That's it. That's how easy it is to read the code. You don't even need to feed that into ChatGPT. You just like literally follow it and the code literally tells you what it does. look how simple it is. If you have like a very basic text editor, you can just like follow the breadcrumbs and arrive at the final result. Easy. Easy. Super easy. I mean, this is primarily because the code is not overcomplicated, right? So the author of this code actually make it as simple as possible, which makes it actually easy to do the thing I'm talking about, right? So if you take a look at the standard library of Rust, it's a completely different story. Of course, I'm half joking as usual. Anyway, alrighty. Cool. So can I just like provide an input for this thing? So we're gonna have in here input txt linearly. All right, and then I'm gonna try to do the input. Right. So the language is going to be English. Right. And what do we have in here? Unknown algorithm English. Oh my god. So essentially what you have to do, you have to put the thing that we generated with that goddamn we need to put uvu in there. So the compiler takes code in Snowball and generates Rust that is not self-contained. You have to take that not self-contained Rust, put it in here, and then is that the like expected use case for this entire thing? I mean, if I was designing this kind of system, I would just make it spit out entirely self-contained code. Like, what's difficult about spitting out entirely self-contained code that I can just like copy to my project and start using? So by the way, so since it's a part of the project, maybe this build is actually called by a makefile at some point. So maybe makefile has something related to Rust. Okay, so it refers to Rust. That's pretty cool. Right, so Rust sources, it knows about Rust sources. It generates... Oh, so we have some code. That's very cool. So we have some code that populates the Rust algorithm or something like that. So Rust src, what is Rust? Okay, so this is literally the folder where we have to have algorithms. So makefile is capable of doing that. All right, so but what's the command? Oh, what's the command of the makefile that I have to... Okay, there is a check Rust, and it's doing check Rust for different... Let's actually try to do check Rust. Right, so let's try to do check Rust. Check Rust. All right, and yeah, it's literally populating this algorithm and stuff like that. No rule to make check Rust Arabic. So it created something like this. Why there is no rule to do that? Let me take a look. Check Rust. So it failed on one of these rules, right? So this is basically wildcard, and if I understand correctly, this part should be one of the languages. So what are we doing here? Output stammer cd Rust. Just gzip. That's a lot of different shite. Cargo flags. So we just unpack a lot of stuff. Does this thing have like a CI? It looks like it does have CI. .github. Or doesn't have a... Idiot! Ooh, Travis! Oh my god, in 2023, who remembers Travis? Who remembers? Oh my god. Damn, this is such a cool rabbit hole. I really love this project. Okay. Anyways, we've got some subs, so let's actually acknowledge them. Membril Amarilla, thank you so much for 19 months of Twitch Prime subscription with the message heart. Okay. Patroclos007, thank you so much for 2 gifted sub. How was my heart, by the way? Was it good? Was it bad? I don't know. So, alright, let's take a look at the Travis, because usually CIs give you insight into how you're supposed to test this entire thing. Right, so let's take a look. So for different languages, here is the script. Right, here is the script. So what they do check Rust, but they also set a variable stemming data, snowball data. What the fuck is the stemming data, and how is it used? Whereas the data files are located, assume their repo is checked out as a sibling. So the check-in requires additional repo that needs to be checked out, and the only way you can know about that is by reading CI. And I mean, if you just made it a submodule, submodules, anyone? I mean, I do understand that submodules suck, but and where do I get that? Oh, this is actually, wait a second, this is an organization. This is an organization, so here it is. Okay. Perl, by the way, okay. And everything's fine, everything's fine. I'm a professional software developer. I've seen shit more cursed than that. This is not the worst I've seen. This is actually fine, by the way. So the fact that we still can figure it out and we didn't hit any like dead ends already makes it an excellent project. Don't get me wrong, by the way. It may sound like I'm shitting on this project. I'm actually not. I'm actually complimenting this project. Like, seriously, this project deserves my compliments. So far, I'm able to follow breadcrumbs and understand roughly how everything works. That's a fucking huge achievement. Trust me. Like, making a project where you can just follow the breadcrumbs and achieve what you want without any documentation, we haven't read any documentation, is a fucking achievement. So props to the author. So don't get me wrong, this is actually very good. This is actually very good. Right. So it's kind of interesting, like, there is this thing, especially with the younger developers. Younger developers and less experienced developers likes to share pieces of code and say, look how shitty that code is. I feel so good about myself because this code is shitty. I would never write code like that. But here's an interesting thing. The fact that you can instantly identify that there is problems with that code and how to improve that code makes that code actually quite good. So in reality, you are going to be faced with the code which is like impenetrable wall, and touching anything with that impenetrable wall breaks literally everything, and you don't even know what exactly wrong with that wall. You can't even point out on why exactly this code is bad. You're literally unable to do that. That's how overcomplicated and impenetrable that is. The fact that you can look at the code and say, haha, this is a copy-paste, I can remove that copy-paste and improve it, that's a fucking excellent code. Fucking trust me, that's absolutely excellent code. Holy fuck. I wish I had to deal with this kind of code every day. Please give me more of that shitty code. You know what I'm talking about? Right. So the more experience you have, the more you're going to encounter this kind of situation, and you're going to be glad to work with a lot of copy-paste. Right. Okay, let's actually try to clone this thing. So far, this is an excellent code base. This is this is the best code base I've ever worked with. Right. Don't get me wrong. So I'm just being over dramatic a little bit because I just had a lot of tea. So anyway. Okay, go. So snowball data, and for different languages we just have this kind of thing, which is kind of cool. All right, so that means I can now go and do make check Rust. Can I do that? Checking output of Arabic. Okay, so it's compiling the Rust project. it's actually compiled the Rust project. So it calls to cargo build. It builds the test app. So it's taking some time though. It's doing important work, exactly, yes. So I wonder if it's gonna do that on each language, or is it specifically Arabic? I don't know. What exactly is it then? Though, if you think about it, stemming Arabic might be actually a very complicated task, more complicated than any other language. It says it's running specifically, so it's extensively testing Arabic language. So, okay, so Armenian. So we're doing Armenian. Maybe it's doing that for each language. Why TF-IDF and not just TF? Because TF-IDF makes it easier to filter out noise, right? So because the idea of TF-IDF is that you take term frequency and divide by document frequency. So essentially, if you have one term that is very frequent in the current document, but it's also frequent in all of the other documents, that means it's a noise. Usually this kind of profile, usually the words like the and a have this kind of profile, right? So because the word the, it might be very frequent in your document that you're currently checking, but it's frequent in all of the documents. Maybe it makes sense to actually ignore it. So TF-IDF kind of does that automatically because you divide by the document frequency or multiply it by inverse document frequency, right? So, but again, one of the primary reasons why I use TF-IDF is because I already used it before, and it worked relatively well for me. So I build up positive associations with that approach. So let's put it that way. Right, so there is like a very technical specific reason why I use that, and there is very less technical reason, right? So because I have some emotional attachment to that specific combination of characters. So Arabic is hard. I'm a native and I confirm that. Oh, okay, I see. So yeah, we can have like a hard measure of how difficult Arabic is by just looking at the time it took to test Arabic language. So yeah, it's actually measurable how hard it is. So I can imagine like how many like rules and exceptions do you need to have to actually stem a word in Arabic language. My God. Okay, so we tested some stuff. So we may try to take a look at this thing. Right. So now if I take a look at that, we have all of the algorithms in here. We have all of the algorithms. That's actually very cool. So include concat environment. Have a look at build RS. Huh. So we include RS. Out dir, and we just generate that thing. So I suppose it should be now relatively easy. Maybe we can just grab this entire module. Yeah. Can we just grab this entire module and just link with it? Right, and then we can use this as an example on how to use that stemmer. Can we do that? That sounds relatively easy to do, except the algorithms use this kind of stuff, which is like part of the environment variable, but maybe. All right, you know what I want to do? I want to make a small break and I want to make another cup of tea. Right, so I ran out of tea. Right, and without the tea, it's kind of difficult for me to move forward, right? To constantly tank the challenges that this repo throws at us. So let's make a small break and yo, it's me, Zozin. How is it going? Did you miss me? Skipping tea. By the way, I just realized I just realized something interesting, boys and girls. So let me try to do the following thing, because I want to keep, yeah. So I'm pretty sure, has anyone like took this folder, like a Rust folder in Snowball, and turned it into a Rust package? Somebody must have done that, or maybe the author of this thing as well. So let's take a look at crates.io, and let's just like search for the name of the library, Snowball. Right. So generic implementation Snowball. Nah, that's not it. So Rust. Okay. So Rust implementation of the Snowballs. Okay. Curry software. So let's take a look. Algorithms. Wait a freaking second. This is literally folder from. Or is it? It's SBL. Okay, so this is not really it. Let's take a look at the source. Well, Snowball, I recognize this. So this is a module, that specific module. Snowball environment, okay. Alright, some people already took it and turned it into a package. But I don't really want to depend on someone else's package, because it's such a simple thing. Right, so the environment itself, the additional code, is actually like 400 lines of code. Like, why do I need somebody's package to do this kind of stuff? So I'm not really sure if I'm sold on using this thing. Oh right, so how you guys are doing? Okay. What's so bad about using someone's package? If it saves you a bit of time, but the saving time is not the goal of my stream. If I wanted to save time, I wouldn't stream. If my goal was to implement stemming as quickly as possible, if the time is only the thing that I care, we wouldn't talk right now at all, like completely. And I would have implemented this thing within like 5 minutes. So obviously, saving time is not the goal, right? It's something else. And I do agree with you, right? So if your goal is to save time, that's literally what you have to do. But then you have to ask yourself, what's your goal? Is that your goal? And if that's not your goal, why the fuck you're optimizing for a wrong goal? All right. While I was making a cup of tea, I actually had a very interesting thought, right, which is kind of like unrelated to Rust integration or anything like that. So if we take a look at the Snowball compiler, it's a Snowball compiler. But do we have a Snowball interpreter? So that's a very interesting question. Right, can I interpret the Snowball things? Right, so if I take a look at the files that are executable, I think like stem words just stems the words depending on the language. It would be kind of cool if Snowball would accept the file, the program, and also like an input file, and would just stem all of the words according to this thing without compiling to any other languages, right? Because it would be useful for example, the developers of the stemming algorithms. Right, for the developers of the stemming algorithm to test your thing without actually do the compilation step and linking step and stuff like that. But it feels like Snowball is incapable of doing that. Right, I wonder if it's... So it's probably located in the compiler. So there is an analyzer, there's a driver, there is a bunch of generators for different things. There's a tokenizer, but there's no interpreter. It would be kind of cool to have an interpreter. Which gives me an idea for a stream. Can I, on a stream, go ahead and hack the thing to be an interpreter instead of compiler? Right. So I wonder which file does have the main grep. Right. So why can't I have that? Because I have to escape. Yeah, here's the main, right, and this is the compiler, so it's within the driver. Disable blah blah blah. Yeah, and you know why this idea is cool? Because I wanted to learn this language. I wanted to learn this language, and by implementing an interpreter, I hope maybe it will be possible for me to learn it, because it's really difficult for me to focus on reading documentation, right? So I rather prefer like working with things, right, interactively, right? I need to sort of like touch the thing to understand it, right? That sounds like a very interesting idea. And here's the thing, people constantly ask me, where do you get all of your ideas for your streams, right? So you have so many interesting and cool ideas, where do you get them? Where's that secret source of all of your ideas? Well, I literally discovered an interesting idea right in front of you. That's how I do that, right? And here's the thing, so somebody, we already discussed that on a break, right? So somebody already took, not stammer, somebody already took the Rust folder and turned it into a package. What I could have done, I could have just used that package and like saved a lot of time and just be done with this problem. But at the same time, would I discover so much interesting shit if I just like slap this thing into my terminal and called it a day? Here's the answer. That's how I discover new interesting ideas, by exploring shit and not trying to get the things done as quickly as possible because it's efficient. You must be efficient in the modern world. You know what I mean? I mean, we forgot how to be curious, right? We forgot how to be curious. Like you just be a little bit curious and all of these ideas are starting to pour in at you, right? I don't know, man. And before, this is actually a pretty bad idea and I will never make a stream, but anyway. Basically, I will, like off screen, I will explore if this is a feasible stream, right? And then we'll see what we can do about that. But that sounds interesting, right? That sounds interesting, right? Because it's kind of like it's kind of an overcomplicated process. If I want to develop a new stemming algorithm, why the fuck do I have to generate the code, then write a program that uses that code, and then compile it? And it's just like too many moving things. I just want to test this algorithm, right? Can I do that? I don't see an interpreter in here. Right. I don't see it. So there's a srcc, but anyway. And yeah. And another improvement that I could have done for this thing is I would make this thing to generate self-contained code, because it kind of sucks that it doesn't generate a self-contained Rust code, like it depends on additional external code. Just kind of weird, isn't it? Anyway, so Yesu. Okay, I'm curious. Can I now just grab this Snowball module and just start using it in my project? Like, I'm really curious. Right. And maybe after all of this exploration, I'm gonna just go ahead and use that package from the crates.io. But I'm gonna use it with the knowledge of how this entire thing works, and with a lot of interesting new ideas for other explorations. Right? That's what's important. That's what's important. I already have a folder Snowball, so let's create something like foo. Let's call it prob. Right. So I already have. Right. So I already have main. Can I do? Can I move main in here? Uvu is useless, right? Yes, I said it. Uvu, your uvu is useless. I'm joking. Alright, and let's try to copy paste this entire thing in here. So this is gonna be Yesu, Kawai freaking desu. Excuse me. Okay, so I'm gonna do Jesus. Snowball. Can I compile this entire stuff? I feel like I won't be able to compile it. Exactly, right, because it includes lang include rs, and it's generated by build.rs. Right, it is generated by build.rs, and I wonder if we can find that specific file anywhere. Right, so what is that file? What is that file? It is generated for debug and release separately. And what does it contain? It contains nothing, right? It literally contains nothing. Why the fuck does it exist? That's a very interesting question. Like, what? So there is a mod in here. Look at the build.rs. Can I just like remove this entire shit? That's actually a very interesting question. So this is gonna be where's that probe Snowball. So this is mod mod rs. Okay, but I have a feeling that this thing is supposed to just, you know, include certain languages in there, right? It would kind of make sense. It would kind of make sense to include them there. So I'm gonna try to compile it right now, and it compiled, surprisingly, right? It in fact compiled. So among us is never constructed, but that's totally fine. That's totally fine. We managed to create this entire thing, right? It says hello world, and that's pretty cool. So let's try to use this entire stuff. Can we use that? Right, so if I do module, we need to do a stammer, I suppose, but where can we find a stammer? I'm gonna go back to here, Rust src main. So it creates a new stammer, match language. So match language. And you call this thing as a function. Man, this is so fascinating, isn't it? Right. So it basically using one of the sort of like existing stammers. That's what it's doing. Oh, it probably wraps them. It probably wraps them. So, So let me take a look. So the algorithm and English, right? And then I do stem, then I just call stem, but I also have to create an environment. And how do I create an environment? I just create an environment from this thing. Okay, I think I'm understanding. We probably don't even need, so this entire sort of generated code is just to adapt a string name to a certain stammer to dispatch between the stammers, but you don't really need that. Right, so if I take a look at the probe, where's my probe? Right, so here's the algorithm. The problem with mod.rs is that it doesn't really import any of these things. I probably have to explicitly say mod English stammer, stammer like so. Yeah, English stammer. And if I take a look at the English stammer, so I just need to have a function, I just need to call the function stem on the environment, and I can construct an environment out of the thing, out of the string. This is very, very straightforward. This is very straightforward. Okay, so let me try to do that. I'm gonna do snowball, right, and snowball environment. I'm gonna create this thing out of linearly, right? So, and this gives us an environment, right? So this is an environment. And within that environment, so I need to have snowball, probably algorithms, right? Algorithms, snowball algorithms, English stammer, stem. I provide the environment probably by this thing, and I don't really know what this thing will return. Snowball algorithm English stammer, it will return a boolean. Okay, that's very interesting. So I suppose it stems it inside of the environment. Right, inside of the environment. So I mean, I can just look inside of the example here. Right, so this is src main.rs, And okay, so the environment actually has get current. Right, so get current. And it returns a copy on write string, which contains the current stamp thing. Okay, so that's very cool. And I wonder if I can do the following thing, where I just do stemmed. We can do it like that. We can say input. So this becomes an input, right? So then we can do output, like so. Equals. And we can say output is environment get current, right? And let's take a look at the compilation errors of this entire shite. rustc main.rs. So let's go to the compilation errors. So private module, okay, so that's understandable, that's easy to fix. We just go into the algorithm mode and we say this one is public module. What else? An environment has to be mutable. Okay, so that means we need to mark it as mutable and pass it as mutable. Sure, makes sense. And it compiles, right? So the compiler actually guides us through how we have to use this entire shit. And then if I run this thing, it stamped this shit perfectly. And now we actually turned this entire thing into a self-contained thing. I can remove all of the other languages that I don't support right now. I'm probably going to support as many languages as possible in the future. Right, but I'm not sure yet how to integrate that into our system. So I'm going to remove everything except English for now, and then I will see how we can integrate that later. So where is English? Oh yeah, I accidentally did that. So let's do that. And I'm going to remove the rest of these things. We're definitely going to support as many languages as possible, right? But for now, to make my life a little bit easier, I'm going to focus only on English, right? So I'm not discriminating or anything or stuff like that. I removed my native language, right? So just to prove to you that I'm not trying to discriminate anyone, I removed my native language. I left only English, right? So it's just, there is a technical reason, right? Just to make it easier. But then in the future, we're gonna just bring them up. So I suppose I need to solve the same problem that the project solves with this generated code, basically mapping certain identifier to certain stemmer, the identifier of the language to the corresponding stemmer, and we'll see how we can do all of that, right? So okay, go. Right. Okay. Let me double check that this entire thing compiles one more time. And we can already literally just copy paste this module to the search engine, right? So I can copy paste this module in here, yeah, recursively. And I suppose I can now say, okay, one of the modules that you have in here is a snowball. There we go. So, and we can now try to compile the main project in here, cargo build. Why do I want to put dot in here? I know what I want. Yes, right before the stream, I was programming in Go. God fucking damn it. Like, right before the stream, because the bot, the chat bot that is currently running in here, it's written in Go. So I was fixing the today command and stuff like that. By the way, for those who didn't know, we finally have a bot that can answer the today command, right? So if you're curious what we're doing today, it can actually tell you, right? I was fixing that functionality. The bot is written in Go, and I was programming in Go right before the stream, and I have the reflex to put dot after build, because that's what you do when you program in Go. You do go build dot, right? Right, but there's no help command, because I've seen your messages, chat. There's nothing that can help you. I'm joking. Anyway, so, excuse me. Let's continue. So what do we have in here? Snowball, publicly used, and it doesn't really work the way I would expect it to work, which is kind of weird, right? Is it not? I think it is. Oh, I think I know why. Right. Maybe we have to do something like super snowball. Or maybe self? Could not find Snowball in self. Use of undeclared crate or module Snowball. Even though maybe I did a fucky-wacky in here, because here's a Snowball. I didn't mod it. I actually put a mod in here. Maybe I have to make it a public? No, I didn't have to make it public. So, can I just... No, I can't really... Unresolved? Use crate. Okay, so it feels like that might be the case. Crate Snowball. Crate. Not crate. I suppose. And that worked without... The only difference between that test example and this thing is that in a test example we didn't use cargo. Right. So why it is important to have this crate when you use cargo, but it's not important when you just use Rust C? Does anyone have any hypothesis? Right, because I'm not a Rust developer, like, and to these days, I don't quite understand how the module system works in Rust. I don't quite understand and why it is the way it is. I kind of got a hang of it, but I still have moments like this. So, does anyone have any hypothesis why when you use cargo, this is important, but when I don't use cargo, you don't have to do that? Is there, like, I have no idea, actually. I wish I could ask ChatGPT, but I don't have an access to it. Right, so... Cargo invokes try-C internally, so I don't see it as a special case. But maybe it invokes it with some sort of flags. Right, and some sort of flags imply like different paths to the module, and that's why it's difficult for it to sort of navigate like through the modules without this additional crate. So maybe you still need to declare a module in a cargo toml even if you vendored it. But here's an interesting thing. I literally copy-pasted into SRC. So there is no difference between vendoring this thing, but like it's almost like I've wrote everything here myself. And I just put it in here. I could have just created a module folder foo. And I don't have to declare it like that, right? You see what I mean? And I think it's about Rust C versus cargo. If you own the SRC instead of depending on the crate, you need to add crate to refer to it. Okay. So, but it works without cargo. So okay. So my conclusion is going to be we don't really know. So maybe somebody on YouTube knows, right? When it comes out on YouTube, maybe some YouTube people will tell us why exactly it is the case, and maybe I missed something. So for now, we're gonna just leave it as it is, right? And we'll see. Maybe somebody will figure out. Maybe somebody with an access to ChatGPT will tell us. Somebody from, you know, a civilized world, not from a third world country. So let me see. Let me see. So the entire thing compiles in here, which is nice. So what we can do now? So you know what's interesting about stemming? You know what's interesting about stemming is that we can use it not only to process the query itself. We can use it to actually create an index, we can make stemming part of the tokenization. When we tokenize, right, so what do we do? Right, so GLSL, for example, I'm going to put comma in here, linear interpolation. First thing we do, we split this thing into tokens. Tokens are a group of characters that have a certain meaning, right? So that means we're going to have the following tokens in here. We have 4 tokens. So the next step that we do, we actually bring them to the uppercase. And we do that so we can interpret these 2 words as the same word. So we basically make it case insensitive, but by bringing everything to the same case, we make it case insensitive, right? So, and another thing that we can do, for example, we can put linearly in here, before building an index out of that, we can stem each individual token in here, right? You know what that means? That means we're going to have less unique terms. We're gonna have less unique terms. I'm gonna show you. For instance, if we have linear red, right, and linear, we can say that these are 3 separate unique terms. But after we stemmed all of them, now we have 1 unique term. So that means on average, we're gonna have less term to work with, which means that the final index probably is gonna take less memory, less space on the hard drive. So right now, the index is actually 3.2 megabytes. What if we also stem the terms before putting them into the index? How much will it shrink? You know what I mean? That's a very interesting question, right? So I'm gonna call it no stem, right? So this is gonna be no stem. Let's go ahead and try that. I'm really curious because it's actually kind of cool. So if that will reduce the size of this entire thing, this is actually quite good, right? Because it grows, I don't know, probably linearly to the size of the folder that we're indexing, but I'm not sure. Actually, I'm not going to make any claims. Okay, so add folder to model, right? So we have a special function which accepts a folder path and the model into which we add in all of that. Also, we accept like how many of the files were skipped just to report that to the user, but it doesn't really matter. Right. So, and then we parse entire file by extension, right? So essentially, depending on extension, we're going to parse the file differently. If it's an XML file, we're going to use XML parser. If it's a text file, we're not going to use anything, right? So we're just trying to extract the text out of the files, right? So then we've got the content, and what we're doing, we're adding the content to the model. We have a special method add document. Right, so model, in fact, I think I did that off screen. I'm not really sure if I did that on the stream. Model is an interface. I think I did that on the stream, but I'm not sure if I'm going to upload that stream to YouTube. We'll see. Right, so model actually is an interface because we have 2 different ways to store the model. We have an SQLite, like a way to store the model in SQLite database and also in JSON, right? So to abstract away from how we store and query the model, this is an interface, right? So I suppose the most important thing in here is add document. I kind of want to deprecate SQLite model. I'm not really happy with it, so I'm going to only add support for the in-memory model. Right, so here's in the memory model, and we do that. So we tokenize everything. As you can see, we just tokenize that. We have terms. And so then we just build the term frequency, but where do we bring all of that to uppercase? Did I move bringing that to uppercase to the Lexa itself? That's a good question. Right. Oh yeah, okay, so the Lexa itself actually brings all of that to uppercase. Okay, it's nice to know that. It is nice to know that. Have you thought about using Levenshtein in the project? No, I haven't thought about that. It's a good idea, actually. Yeah, how can we do that? We can essentially bring to uppercase to make it case insensitive, then stem it to get rid of the inflections. And what are we finding a distance between things? We're finding the distance between stems already, right? We're finding a distance between stems. But the point of stem is that related words map to the same stem. And if we have two stems that differ at least by one character, are those stems related? That's a really interesting question. Like, essentially you have several words. You can say that those words are related by bringing them to the same stem. Then you have several stems. Is using Levenshtein distance to find similarity between the stems actually work? Because even a single character change in the stem may actually result to those stems not being related. And so we may potentially clumping together things that are not related to each other. You know what I mean? But that is a very interesting idea nonetheless. That is a very interesting idea nonetheless. Thank you. I'll think about that. See if the linguists have some concept containing stems. Yeah, it actually probably depends on the specific stemming algorithms and what were the intentions of designing it and stuff like that. Right, so I think to answer that question, you need to like literally understand the stemming algorithm, the specific stemming algorithm, and then maybe we can get some insight whether it's possible to use that. But yeah, thank you anyway. All right. So let me see. So here's an interesting thing. When we stem a certain thing, we have an environment. An environment is stateful. As we feed the data into the environment, we modify its state. But then if I want to stem a different word, how do I do that? Do I have to reset the state of the environment? I feel like I have to do that. So let me actually take a look at the example of Snowball. Right, so this is Rust. Okay, so I do the stem and I get the current thing. So how do I use this? How do I create the stemmer? Stemmer create. So we read the file. We split this entire thing by lines, right? So this specific test application actually, I suppose, basically stems each individual line. Right, and in here, what we do, we just stem it. And stemming it is creating a new environment. Okay, so you do need to create a new environment, but you actually, like, you do need to reset the environment, but you reset it by actually creating a new one. Is that too slow? Right, is this an expensive operation? So that's a very interesting question. So when you create it, you just create like a single object. Replace as, feels pretty lightweight. It's not doing anything. It's a very lightweight object. Okay, so that's totally fine. I don't know why I'm being so worried about. What I'm being so worried about. I can't speak English anymore. Right. So model. So, and it should be pretty straightforward. So Snowball environment. So maybe it would make sense for me to just take that specific example in here and like literally create an environment, and then here I'm gonna just stem into that environment, and the stemmed token is basically this, right? Stemmed term. Let's put it in here, and there we go. So, and so it's already kind of a reference, so that means I should be able to do stemmed term. Stemmed term. So I didn't use term. Okay, so that should be it actually. That should be it. And let me try to build the entire thing. It's probably not going to build, right? Because we need to import some of the things in here. Not found Snowball. Crate. Not create a crate. Don't tell me how to do that. Okay, if it works, I'm gonna fix it later, right? I'm gonna fix it later. Don't worry about that. So it kind of looks ugly, but my point right now is to make it work. Right. So that's my goal. Okay. So in here, expected found cow. Help borrow here. Okay. So can I borrow that? So what do we have? Is not implementing borrow, copy and write. I'm not sure how do we use this thing. Can I do toString? Right. Just basically I want to make it owned. Yeah, there we go. So that's reasonable enough actually. Okay. So we've got that. And I think we're ready to try to index the folder. Okay, so without any stemming, this is 3.2 megabytes. What if we now try to stem this? Release, index, docs.jl, and let's go. All right, so let's wait a little bit. In fact, a fun fact, fast and car have a Levenshtein distance of 2 in Arabic. Oh, that's actually pretty cool. So the car in Arabic has a completely different root than in English, for instance, right? Because the origin rather origin, right? So because the origin of a car in English is a carriage, right? So it's basically like a horseless carriage, right? But in Arabic, it's something about movement. It's something about speed. So its origin is different. It's really interesting, like. Actually, okay, so it's the same size, surprisingly. Okay, so well, it's not necessarily the same size, right? So maybe the difference is like actually negligible. So that could be the. No, it's literally the same. Did I do something wrong? Did I do something wrong? Okay. All right. So let me see. So this is in the memory model, add document. English stemmer, stem, and then I add the stem. So I add these things in here. This is truly sus, not gonna lie. This is truly sus. Sus. Cargo. It must be smaller. It just must be smaller. Like, it's not really must be smaller. It must be different. Because we're tokenizing things completely different now. So, yeah. What if I embed the stemmer into the Lexa? That's a good question, actually. What if I embed it? Right, so... Oh, yeah, it's actually even better. It's actually even better because it's going to be applied automatically for queries as well. Yeah, so that's actually pretty cool. So next token, we update this entire thing, so and it returns just that. Oh, yeah, here's the interesting thing. And you want to apply it only to alphabetic things, right? So it's only for alphabetic things. So here we just chop this entire stuff and we collect it into a string. Right, so this is going to be term, right? So this is just a term. Then we do that, and then we have a stamped term, which we can simply return, right? And for the model, we just return to the term. Okay. All right, makes sense to me, hopefully. All right. Okay, so doesn't know size at compile time. So what I want to collect it into, I want to collect it into a string. All right, that makes sense. Okay, so model, and by putting it in here, it also should work for SQLite model as well. So it should work for everything. So it's part of the processing of the tokens. So that makes sense. I may want to actually double check that it does exactly what I expect it to do by just testing it, right? So we can go to here and let me comment out those things. I'm going to have input, which is linearly, GLSL linearly, interpolation, sure. So we're gonna do Alexa. In Alexa, I create one from the characters. So can I just have a characters like that? I wonder. From this thing. Exit code. I can just return exit code. Success. Yeah. Okay, that's cool. So then for term in Alexa, new input, right? And then I can just do it like that. I'm pretty sure I'll have to collect it into a vector, so that's totally fine. So term like so. All right, not in the scope because I have to probably import it, but I don't really have that much time. Okay, so this is iterator, so I need to collect that entire stuff, and I'm probably gonna just collect it into a vector, right? So, like so. Okay, show me everything you've got. Probably gonna even run that. This is truly sus. Yes. I'm applying all of that stuff in a wrong order. I'm applying all of that stuff. Oh, and it even expects... Okay, so what if we don't do uppercase? Right, it looks like the stemmer generally wants things to be lowercase. Right, so let's actually do the lowercase, uppercase, lowercase. I think it like generally is going to be easier to work with. Right, so this is going to be lowercase. Yeah, there we go. Interpol. Interpol. Okay, so that's cool. GLSL linearly interpolate. Yeah. Okay, that is very poggers, my dudes. That is very, very poggers. Absolutely fucking poggers. Alright, so let's do a build. None of the Interpol's business, yeah, exactly. Okay. So now I'm gonna try to index this entire stuff. A go. Interpol kinda sus, yes. I do agree with that. It is kinda sus, not gonna lie. Oh, it's compiling. Stem. So we call function only in a single place. Okay, so here we indexing stuff. All right, so there we go. This is what I'm talking about. It did in fact made it smaller. Not that much though. Well, I mean, 400 kilobytes is actually reasonable enough actually, if you think about it. Right. So this is with stemming, this is without the stemming. But I mean, it can grow, it can accumulate the more documents you have. Right. But the goal was not to make it smaller, by the way. The goal was not to make it smaller. The goal was make it more robust when we query things. Right. So that was the goal. And since we already stem in Alexa, right, since we stem in Alexa, it should be really easy to test that, right? So we don't have to modify anything. So we can do cargo, run, release, right? So, and then I can say serve. So this specific, not really this specific folder, but that would be actually kind of cool. It would be kind of cool if you can provide the same folder as for index. In fact, in the future, I want to get rid of the index subcommand. I only want to have a serve subcommand to which you put a folder. And basically what I would expect this thing to do is to actually index it and put the index inside of that folder, right? Or maybe nearby if you don't have a right access to that folder, it doesn't really matter, right? And essentially, as you add more files to that folder, it should detect that and index in the background, right? Do additional indexing and stuff like that. So I want this index process to be completely transparent for you guys, right? So essentially you would say, okay, just index that folder. It would start working immediately. It would start serving the website immediately, and then it would index in the background. Right, and as it indexes more, the search results become better and better because it adds more information, something like that. This is just my end goal. Right, but for now it works like this. We have to just, not JS, but JSON. Okay, so it is running. So let's see if it does anything. GSL linearly interpolate at sample. That's already interesting. Linear interpolation. We actually discovered more documents, right, that we never seen before. Interpolate at sample. Okay, interpolate sample. Sample varying in location specified sample. Interpolate to be sampled at location. Huh. But does it contain linear? It doesn't contain even linear. That's very interesting, but I put linear in here. Line. Interpolated sample. Linear or linear interpolation. But I mean, mix is up there as well. Mix is up there as well. Bind texture. Create texture. Bind texture. But doesn't create it, because it's not really create, it's generate texture. No, it doesn't contain it, but there is a create texture down there as well. Bind texture. All right. So projection matrix, for instance, matrix mode, right? So there's some, yeah, there's gel push matrix and stuff like that. So it's kind of interesting. So linear. Interpolation. It's reasonable enough. I would expect mix to be at top, but I'll try to investigate what exactly is going on with that. Yeah, we have stemming, right? We have stemming. So one of the things I would like to do in terms of testing all of this algorithm, maybe in the future I want to add the PDF format. Or something like that, and we just go to our Xif. How do you call this thing? Yeah. How do you pronounce the name of this website? Is that Archive or something like that? Is it like later? Right. So just download a bunch of computer science PDFs and try to index them. That would be actually kind of cool. Yeah. So I don't know, is there anything on sorting algorithms? Right, is there anything on sorting algorithms? Sorting algorithms. Right, because there's a lot of stuff to just like test this stuff on. It is archive, yes, okay. Okay, so yeah, so we have a stemmer now, right? So that means we don't care about inflections of the words. So that means GLSL linear interpolation, right? And linearly doesn't affect the result. Linearly doesn't matter, right? Because it's these two terms map to the same stem anyway, right? And this was kind of the goal of today's stream, right? So this thing doesn't matter, though. Yeah, it doesn't matter. Yeah, so it basically results in the same thing. So the goal of stemmer is basically make it like more stable, I suppose. But again, I'm not a specialist in NLP, right? But it feels like it just to make this stuff more stable, because like different inflections don't really affect the final result. It would be, you know what would be even cooler to improve the search, to improve the relevancy of the search, so to speak, is to have a dictionary of synonyms, right? So, and take different stems, right? Take different stems and map them to the same synonym, basically generalize it even more. You know what I mean? So that way, maybe we can even decrease the size of the index even more and make the search even more relevant, hopefully, or maybe even more stable, right? Because different synonyms of linear I don't really know any synonyms of linear, right? But if the like linear and other synonym of linear map to the same thing, we don't have to worry about this kind of stuff. That's basically an AI, is it? Is that what AI is all about? It's just like mapping things in dictionaries or something like that? Are you planning to implement stop word filtering? It should reduce the size of the index and may speed up indexing and querying. That's a good idea, actually. Yeah. I was thinking, by the way, about the following approach, right? So determine the stop words by how noisy they are, right? As we already discussed before, inverse document frequency is really good at automatically detecting the noise and filtering it out. Can we use kind of the same approach to determine the noise words and never actually like index them or just basically ignore them? Right, so we can do the first like index, then we can see that dots and commas are very frequent in all of the documents, and then we put them in the stop word list automatically, all of that automatically. Do the second indexing, and on the second indexing, they are actually filtered out completely. Something like that. I'm not sure if it's a good idea, because I've never done this kind of stuff before, but this is just like my random thoughts. But I suppose usually when people say like stop word filtering, they mean like manually curated list of stop words, right? Does it have to be manually curated, or is there any algorithm that, as I just described, to determine the stop words automatically? Right. I mean, there should be some sort of like algorithm, right? So you can assign some sort of metrics to, like a training step, yeah. You haven't seen that before? Like, I don't know, I also haven't seen that before because I know nothing about this area. It's all very new for me. The stammer already discarding all of that? I'm not sure, like, the is probably stamped to the. No, I don't think stammer is actually, you know, figures that out. I don't think so. But anyway, I'm already streaming for 2 hours and I'm a little bit tired. I think today's stream was very educational and very interesting. We explored a very interesting project, Snowball, right? I really recommend to check it out. Right, so, and yeah, maybe I'm gonna try to learn this language and see if we can, you know, make it an interpreter, because I think having a Snowball interpreter is actually a very useful thing, and also a very interesting thing to stream, right? Because it's basically a language development stream. Do you guys like language development? Right? Because every time I develop a new programming language, I have like extra amount of views. So I make a judgment that people really like when I develop programming languages, right? I don't really know why, because programming language development for me is as interesting as doing like a OpenGL shader programming, right? So for me, it's just like different kinds of programming, right? And sometimes I don't understand why for some people, one kind of programming is more interesting than another kind of programming. It's all programming for me. Right, so you're dealing with these algorithms and stuff like that. But yeah, my hypothesis is that for many people, programming language is sort of like a mysterious thing, right? So usually, how do you become a programmer, right? So you use a computer, and the computer does a lot of magic, and then you discover programming, and like a huge chunk of the computer magic instantly got demystified for you. You can now see, oh, this is how you make computers do these magical weird things. Okay, that's cool. But how do you make that magical things that allow you to do these magical things? And this is like another mystery. It's like another layer of mystery for you. Right, so you basically broke through one layer of mystery, but you hit with another one, right? So you have a magical tool that does this magic, but how do you create such magical tools? So it's another layer that you need to penetrate through, and and that's why probably a lot of programmers are interested in this kind of stuff, because like, how the fuck do you do that then? And yeah. All right, okay. that's it for today. I hope today's stream was interesting. It was definitely interesting for me. So thanks everyone who's watching right now. I really appreciate that. We got some subs that I didn't acknowledge, like one sub. Evil Rocket 216. Thank you so much for tier 1 subscription with the message Tsodin indeed. And yeah, thank you so much for watching, and I see you all next time. I love you. Mwah.